This is John here, and we are back with another foreclosure problem. This is problem 114, global take while. Medium difficulty here, and it says take while is great for filtering, but it's limited. You can only examine a single item of the sequence at a time. What if you need to keep track of some state as you go over the sequence? So we are going to write a function which accepts an integer n, a predicate p, and a sequence s. It should return a lazy sequence of items in the list up to but not including the nth number that satisfies the predicate. Alright, so we need to keep track of some state here. So let's set up a loop, and we'll have our n that we're going to decrement as the predicate is satisfied. And then the sequence is going to shrink as we go. So we're going to loop through that. Predicate's always going to be the same. So we don't need to put that in our loop. Okay, so let's start with our termination condition. And our termination condition is that S could be empty, so if we can say if S is empty, or if N is less than 1, we want to stop as well. And what we will return then, we should have an accumulator. So let's have our empty vector as our accumulator. Okay, so if all that happens, then we are going to return our accumulator. Otherwise, let's see, we want to test the predicate. So we will I'll do the predicate function on the first element of our sequence. Oops, and we're missing or here. Okay, so if the sequence is empty, then we're done, or if n is equal to 0, then we're done. Alright, so if we're done, we just return the accumulator. We run our predicate, which will decide whether we're going to decrement n. Alright, so let's let our new version of n equal if all that, if the predicate on the first of our sequence is true, and we're going to decrement n, otherwise we'll leave n alone. Alright, and then we are going to recur. So we are going to recur. Oops, I need to be inside this let. Alright. We're going to recur with our new value of n, rest of our sequence. And also our accumulator. And here's the trick. We need to know whether the predicate passed or not. So let's make a new variable pass, which is this thing. So now we can say if our predicate passed, then do that. So our accumulator, we're going to say if, no, that's not what we want, because we only care about n, not if it passed. Okay, we're going to say if n is greater than 0, that's probably the same up here. Alright, so if n is greater than 0, then we are going to conj onto the accumulator the first value of s. Otherwise, we'll just return the accumulator without adding anything to it. I think that's right. We'll call it GTW for global take while. Did not. Oh, yeah, backwards. Variable name, initial value. Okay. So now that all compiles, we can test it out. And put GTW here. We got false, so we have an error. Let's just execute this to see what it returns. It returned nothing. So we probably just return the accumulator right away. So we have in our predicate and our sequence. So when that comes in, does it say S is empty or if n less than 1. Okay. So no, n less than 1. Okay. Alright, so that worked. Let's try another one. GTW. And that one worked. GTW. And that one worked, so this seems to be our solution. So let's just turn that into a function. Copy, paste. Let's see what we get. Green, green, green. We got it right. All right. See what other people did. Yeah, that one looks different. Map first, take while. Alright, lots of way different solutions, but I don't see anything that's pops out as something that's just way better. So let's just be satisfied with what we got. Alright, thank you for watching.